Now so far we have derived this formula. Pressure due to gas P equal to 1 by 3 mn Vrms square. M is mass of one of the molecule and small n is number of molecules per unit volume, sometimes also called number density. So if alright, so this m, first I will adjust this formula to so that I could easily correlate it with the gas laws. So P equal to 1 by 3 small n. Small n is actually capital N upon V. This is volume and Vrms square. And n multiplied by m multiplied by n is actually mass of the gas, total mass of the gas. I am using symbol W for that because sometimes wrongly it is called weight of the gas. That is why W I am putting. And we know that relation number of moles equal to given mass of the gas upon molecular mass of the gas. So from here we can write it 1 by 3 mu m upon V times Vrms square. Now for given mass, for given mass of gas, this term number of moles will also same and m is molecular mass. So this quantity mu m is constant. Actually m is constant, so number of moles are also fixed if we have a given mass of gas. Okay, now case 1. For constant temperature, this Vrms square is also constant. Actually, this is the velocity acquired by thermal energy and it has direct relation with temperature. So later on we will decode this also, but right now this entire term is constant, so we can write P is inversely proportional to V, and which is Boyle's law. So this is Boyle's law. So in Boyle's law, if you could remember that we say that if temperature remains constant, then for a given mass of a gas, pressure is inversely proportional to volume. So from here, we can explain that. Now, Charles' law. Okay, once again, for constant pressure, so we have to interchange this. We will cross multiply V here and we can shift P here. So for constant pressure, V is equal to 1 by 3 mu m upon P and Vrms square. That is, V is directly proportional to Vrms square. And this Vrms square is directly proportional to kinetic energy. And actually, for gaseous molecules, their kinetic energy is directly proportional to their temperature also. So it was observed that, this is a cheat note in the side, Vrms square is proportional to temperature. And this concludes, why so? Because this is also proportional to kinetic energy and this is also proportional to kinetic energy. And that is why we can conclude that V is directly proportional to P, which is Charles' law. And then there is pressure law, sometimes also called Gay-Lussac law, but Gay-Lussac has given some other law also of partial pressure, so that is why I am not naming it. So at constant volume, so it is quite evident that for given mass, this is constant, and we know that this Vrms square is proportional to, first we will have this pressure is directly proportional to Vrms square. Why? Because volume is constant. And because of this argument, we can write P is directly proportional to T. So this is how we can conclude what is it actually, how these gas laws can be explained on the basis of kinetic theory.